Welcome to the Explainer. So today, we're tackling a really foundational skill in networking, and that is subnetting. If you've ever stared at a massive block of IP addresses and kind of wondered how network engineers chop them up into manageable pieces without, completely losing their minds or spending hours doing math, well, you are exactly in the right place. Subnetting is absolutely vital for efficiency, but let's be real. The traditional way of doing it feels incredibly slow. It's tedious. But today, we're going to change that. We're going to learn a brilliant shortcut. But before we get to the shortcut, we've got to understand the rulebook, right? Every IP address class comes with a default subnet mask. You can think of a subnet mask as a 32-bit boundary line, literally made up of ones and zeros, and its whole job is just to separate the network address from the host address. Now, relying on those defaults, that can cause massive inefficiencies in your network design. So to fix that, we really have to master subnetting ourselves so we can dictate exactly which bits belong to the network and which belong to the hosts. Whenever we subnet, we have three really clear goals. By the end of this explainer, you're going to be able to take a network and instantly identify the network address, the broadcast address, and the exact range of usable IPs. We're going to look at the traditional method first, just to set the stage, and then we'll unlock that shortcut that literally changes everything. Okay, section 1, the long way, binary translation. We really need to see this procedural method first so we can truly appreciate the magic of the shortcut later on. All right, so here's our example. Let's start with our target network, 10.29.32.0/27. Now, I want you to pay really close attention to that /27 at the end. That number is crucial. It tells us exactly how many ones are active in our subnet mask. So if we were doing this the traditional way, we'd use the binary translation method. Step 1, you literally translate the subnet mask into this massive string of ones and zeros. Step 2, you translate the IP address itself into binary. And then step 3, you visually line them all up to slice the network and host portions apart. Honestly, it's an absolute recipe for hand cramps and human error, just writing out 32 bits on a piece of paper over and over. Here's what that breakdown actually looks like. Because our target network uses a /27 mask, we have exactly 27 ones locking down the network portion. And since every IPv4 address is exactly 32 bits long, simple math leaves us with exactly 5 zeros. Those 5 zeros, those represent our host portion. Okay, now that our host portion is isolated, we can identify our key addresses. To find the network address using this long method, you have to set all those host bits to zeros, and then convert that whole binary mess back to decimal. When the host part is all zeros, boom, you get your network address. Pro tip though, usually you can just copy what's already provided to you. So in our case, it's just simply 10.29.32.0. Now, finding the broadcast address requires the exact opposite action. Instead of zeros, you flip all those host part bits to ones. When you convert that binary back to a decimal number, you get the broadcast address. For our /27 network, that whole process translates to 10.29.32.31. And here is the absolutely crucial takeaway. You cannot assign a network address or a broadcast address to your actual devices, like your laptops or servers. They're strictly reserved. That means everything mathematically sandwiched in between those two numbers represents your usable addresses. So from .1 all the way to .30. Meaning the total number of usable IPs for this specific subnet is exactly 30. Now, I don't know about you, but manually writing out 32 ones and zeros every single time I need to map a network sounds completely exhausting. And it's incredibly prone to human error too. Which naturally brings us to a very important question. Is there a faster way to subnet without translating everything into binary? The answer to that is a resounding yes. Let's move right into section 2, the subnetting shortcut. This is where we get to bypass those ones and zeros entirely. Just look at the visual contrast between these two approaches. On the left side, you've got the traditional, visually dense method of manually mapping out 32 bits. That's a lot. But on the right, the alternative, simple subtraction using just the subnet mask number. It's an incredibly elegant, super fast mental model. All right, so here are the 3 simple steps that completely replace that entire binary translation process we just did. First, subtract your subnet mask number from 32. Second, take that result and calculate 2 raised to that power. And third, the resulting number becomes your magic increment. That's it. Let's actually see it in action. Going back to our target network, we know it's a /27, right? So step 1, take our 32 total bits and subtract our subnet mask of 27. 32 minus 27 equals 5. Just like that, in a matter of seconds using basic math, we know we have 5 host bits. No binary needed. Now, step 2 is finding our increment. We use the formula 2 raised to the number of host bits, so 2 to the 5th power. That gives us 32. This number, 32, is our magic increment. And by the way, if you don't have a calculator handy, don't worry about it. Network engineers usually just memorize or keep a simple reference table for powers of 2. So armed with our magic increment of 32, let's jump into Section 3, calculating usable IP addresses. Remember a minute ago how tedious it was to flip all those host bits into ones and then convert them back to decimal just to find the broadcast address? Yeah, throw that out. Here is the shortcut formula. Take your network address, add your increment, and then subtract 1. Let's plug our actual numbers in. Our network address is 10.29.32.0. We take that final 0 in the 4th octet, and we add our increment of 32, which takes us up to .32. Finally, we just subtract 1. That leaves us with 10.29.32.31. Look at that. We literally arrived at the exact same broadcast address as the long method, but we did it in our heads in, 5 seconds? Finally, we need to find the total number of usable IPs. Instead of trying to count everything that sits between the network and broadcast addresses, we just use this brilliantly simple shortcut formula. Simply take your increment and subtract 2. So our increment is 32. Minus 2 gives us exactly 30, meaning we have 30 usable addresses, ranging from 10.29.32.1 all the way to .30. It really is that simple. By just subtracting from 32 to find the host bits and then calculating your increment, you unlock the entire subnet without touching a single 1 or 0. And listen, the speed isn't just some neat party trick. It's the difference between actually passing a certification exam like the CCNA or running out of time. It's a difference between really swift troubleshooting and hours of painful network downtime. You've just completely mastered the /27 subnet using a highly efficient mental model. But now it's time to put your new skills to the test. Before we wrap up here, I want to leave you with a quick challenge. Using this exact shortcut method we just walked through, how fast can you calculate the network address, broadcast address, and usable IPs for a /24 subnet? Try applying the subtraction and that increment rule right now. I promise you, once you start using this shortcut, you are never going to want to go back to binary translation ever again. Thank you so much for joining me on this explainer, and hey, happy subnetting!